Kia ora everyone, we are still working on our bouncing ball, but here we are on Google Jamboard just to do a little bit of an explanation about how we're going to get this ball to actually bounce. In order to do that, we need to know a few things. We need to know what it's bouncing off, and that seems pretty obvious, right? Well, it's bouncing off the edge of the screen, but we don't have anything in our program that actually says what that is. We can't just say, if you're on the edge, bounce. We don't know what the edge is at the moment. So we need to put that into our code somehow. So let's say, for example, and I'm doing this with a mouse, so it might be a bit messy, but say, for example, I have my canvas, and when the ball is coming through here, I want it to be able to hit that side and bounce. And I want it to come up here, and then I want it to hit that side and bounce, and then come down here and hit that side and be able to hit that side as well. So we need it to be able to hit the right, left, top, and bottom. Cool. Where are those things? Well, our canvas has two main features, right? It's got this here. And what's that called? It doesn't matter what that number actually is. It's called width in us. And I'm not going to try to write that by hand just using my mouth. My mouse. I'm not going to try using my mouth either, but I'm not going to use my mouse. Maybe we could start again. But no, we'll persist. Typos, errors, faux pas, and all. Okay, this one up here, of course, is called height. And a canvas has got a width and it's got a height. What are those numbers? It doesn't matter. We want to write our code in such a way that it doesn't matter how big our canvas is. The ball is going to bounce off the edge regardless. So my ball's coming along here. It also has two things. It has an X position and it has a Y position. As it's traveling this way, and eventually it comes through and it hits this edge, how are we going to know that it's hit that edge? Well, its X position is going to be greater than width. Yeah, we got there. So X is greater than width. On this side, X is greater than width. If at any point, regardless of what's happening with Y, if X is greater than width, we need to bounce. And in the same way, as it's coming up here, don't forget in Python Arcade, 0, 0 is down in this bottom corner. So as it comes up here, up the top there, if the Y coordinate is greater than height, we also need to bounce. We need to bounce in the Y direction, right? Okay, so it's come along here. Ooh, let's use a laser. It's come along here, it's bounced, and then it's gone up here, and it's bounced, and now it's come down here, and at the moment it's still just going to keep going forever and forever. We need to bounce off the side. Pause the video, have a think. What do we need to do in order for it to bounce off the side? Well, we need to say if X is less than 0. Then we need to bounce in the X direction. And once the ball, I'm going to get my laser back, as it comes down here, if Y is less than 0, we need to bounce as well. So the things when we need to do something is X greater than width, X greater than width, X less than 0, Y, of course, I haven't written in, but Y greater than height and Y less than 0 down here. All right, let's get coding. This is the complete code from the sketch we wrote last video. Hopefully you've got this and you've completed that. If you haven't, go back and do it. That's what we're going to be editing here. So what we need to say is, first thing we need to do is we actually need to give it some velocity so we can change it later on. At the moment, we just programmed it in with literals, and forever and forevermore until we stop the program, it's going to keep moving in that up and right direction because we're just adding 5 to its X direction each time and 5 to its Y direction each frame. But if we're bouncing, we want to be able to change that. So let's give it some velocity. Let's say velocity x is going to equal 5. Velocity y is also going to equal 5. And just like we did before, we're going to bring that into the onDraw function using that global keyword. So global velocity x and global velocity y. Okay, cool. So now instead, speed is the change of distance over time. So distance over time. So each frame, your speed is going into your position. So we're going to change our position by our velocity each and every frame. So vel x. So x plus equals velocity x and plus equals velocity y. Speed is the change of distance over time. Great. Okay. This should run with no problems. Let's check that first, make sure there's no errors. It's probably going to take a tiny second to think about running for the first time today, as it's loading Python from memory and bringing an arcade from memory and doing all that other good stuff it's got to do from the first time. Here we go. Ta-da! When you're ready, feel free to just skip past this part. I'm going to stand here and wait. Do a little dance while I'm waiting. Nothing happening so far. Okay. Hey, yes. Next step. There it is. There's our lovely maroon background, our lovely pink ball. Off it goes. 45 degrees. 5 pixels in the X direction every frame. 5 pixels in the Y direction every frame. Love it. Okay, let's make it bounce. What did we decide? First things first. We're going to say if x is greater than width, then what? Bounce. What does it mean to bounce? Well, we want to, instead of, as we're traveling along, let's just get that frame back up. Oops. It's not going to let me do that without pass there. By the way, pass is a very handy keyword if you've written a statement and you haven't finished it yet. The other option, of course, is to just use the good old comment and just comment it out. So as it travels along, we know what it means now to hit the end of the frame, but what does it mean to bounce? So as it's coming along, and I'll just use my mouse for this, it's going to hit this edge, and so it's x velocity, we want it to invert, to swap. So instead of traveling right, we want it to travel left. And what does that mean? It's change of x, which is its x velocity, needs to go from positive to negative. Positive this way, negative that way. Let's do it. So if x is greater than width, we need to say velocity x equals negative velocity x. Yay. Here we go. Drum roll. Are you ready? Here we go. Yes. It's getting close. And yes, it worked. Woohoo! Success. And then it immediately went off screen because we haven't done the y-axis yet. Let's do the y-axis. So if x is greater than width, if y is greater than height, then velocity y equals negative velocity y. Love it. While we're here, let's see if we can do the whole thing. And just say, whoa, watch that tabbing. There we go. If velocity x is less than 0, never mix those up. Don't get your greater thans and less thans mixed up. It happens to the best of us, and in the silliest of circumstances. This should be fine. This should still work because if, say, for example, my x velocity is negative and it's coming left and it's going to hit the edge of the screen and go boop, what's a negative of a negative? It's a positive. So we should end up, boop, have a positive x velocity. Let's watch this working. I'm just going to Control S that there, save it. Here we go. Oh, that was much faster. Nice. And bounce, and bounce. Yes! Very, very good. Here we go again. Bouncing and bouncing. Great. And it sort of seemed to be stuck in this rectangle. But hey, that's great. It's working. Cool. But do you see how it's bouncing off the middle? That's because our ball, its coordinate is defined by its center point. The middle is where we are drawing the ball from. So when we're actually bouncing, it has no idea about the size of the ball. The ball could be twice as big. It would still bounce off the center. Let's do it. Let's change the ball's radius as just a single number here. Let's make it huge. Let's make it 75. Absolutely huge. And yes, it's bouncing off the center still. Looks a bit strange. Let's set it so that it is bouncing off the edge of the ball. How are we going to do that? Okay. Let's give the ball another property, or let's make another variable, I should say, called radius. Let's set that equal to, let's make it something sensible like 50. Pull it in. We actually don't need to pull it in because we're not changing it. So it can stay put, I believe. Maybe I'll be wrong and I'll have to fix that in 5 minutes. But let's set the circular radius here. So radius. Okay. And then we are going to, what are we going to say? We're going to say if it's greater than width minus radius. And it's worth explaining what's happening here. So as the ball comes up, oh, this is a circle, wonderful. And it touches that edge. It doesn't matter what direction it's traveling in. It has a center point there. Maybe a center point there, which has our x and a y, but we also know this distance, which is that radius. We know that radius. And so if we say, look, if that center point is, I'll just do a little dashed line here. That center point, if the x is beyond the width minus the radius, well then this edge is going to appear to be touching the screen. So it's going to give the illusion of bouncing. And then you realize that all coding and all animation and all computer graphics is illusions anyway. And you just accept it and go, that's the way we do it. It is bouncing off the screen, as good as we could ever hope to animate it. Okay. So, same thing here. If velocity x is, if y is greater than height, we need to minus radius. But here, if x is less than 0 plus radius. And we don't need 0 plus radius, because of course 0 plus anything is just the thing itself. So you can say that, but positive because it's on the other side. So we're trying to move it inside this way, right? Radius is going to be here, and we want to say, and so eventually your box is going to be a little bit smaller in the eyes of the circle. The circle's going to be bouncing around a smaller box using its center point, but that's going to give the illusion of it bouncing off the edge of the circle. So if y is less than radius, then velocity y is less than, or that velocity y equals negative velocity y. Here we go. Here we go. And oh yeah, looks good. Looks very good. Cool. I want to do one more thing before we leave this alone. I just want to tidy this up because something is bothering me. If I set the ball, if I set its position to be outside the bounds of the box, or for some reason, for whatever reason, if it skips a frame and it ends up past that boundary, it's actually just going to sit and bounce back and forth and back and forth. I'll show you what I mean. If I set its X and its Y position now to be something like 2020, which is, again, that's smaller than radius, and so what it's going to do is it's going to its velocity X is going to become negative velocity X, and then in the next frame it's going to become negative velocity X again, and then the next frame it's going to become negative velocity X, so it's going to go from 5 to negative 5 to 5 to negative 5 to 5 to negative 5. Same thing for the Y, back and forth and back and forth and back and forth, each and every frame, 60 times a second. Let's take a look. Oh, not good, not good. What can we do? What can we do about this? Okay, well, if it's down here, I definitely want its Y velocity to be positive. I definitely want its X velocity to be positive as well. They're shooting that way. Oh, that's hard to do. That way? Oh, that's better. But I hit the edge. Ha. Okay, so there's one way we can do this, and that's by using the absolute value. And what does the absolute value mean? It's just ignoring negative signs. So the absolute value of negative 5 is 5. The absolute value of negative pi is pi. The absolute value of negative 365 is 365, right? If x is greater than width minus radius, so if it's outside the rightmost bound, so what's that saying? I want it to become negative the absolute value of x. Why are you not turning yellow? You should be turning yellow. Oh, that's just the color. So you can hover over it there. It's saying return the absolute value of the argument. The argument being velocity x. Great. And so here, same thing. I want you to be negative the absolute value of y. And here, if you are outside the leftmost bound, if you're outside this wall here, I definitely want you to be positive. So I just want you to be the absolute value of x. So it doesn't matter if you had a negative velocity when you got there. I want it to be positive now. This can save you a lot of strife if you're trying to collide off things and you're trying to bounce off things. Say if a user is controlling the mouse and they're moving it really, really fast, faster than your 1/60th of a second update frame, things can end up inside other things and you just want them to separate and not sit there and jitter forever. It's just something to have in the back of your mind. Let's see if that fixes our problem. Did you fix my problem? Do I still have it open? No, maybe I did not click the button properly. That'll be it. That'll be the silly reason why for it to not work. Here we go. Absolute values, bouncing ball with absolute values and negative absolute velocities. There it is. I think that was just hidden for a moment. Let's try it one more time. Load up for me. There it is, straight away. It's just fixed. It just leaves that little jittery space it had down here, and off it goes straight away. Wonderful, we're done. This is not the best way to code this up. we're going to do it slightly differently next time because I have one ball and I want another one. I want another one on the screen. Why not? Let's do it. On the next video, that is, we're going to make a second ball bounce around the screen. We'll see you there.